Yes, hi, hello everyone. Good evening. I hope everyone is doing good. This is your Ameer sir, Master Teacher of Physics at Vedantu. So it's been so long, isn't it? I know that it's my fault because this class of Nuclei was supposed to be happening on Monday, right? Because due to some personal issues, I couldn't come live. I hope you can understand, right? But no worries, with full impact and with so many amazing questions, we are here again with the Rapid Sprint 2.0 and with the topic of nuclei. And I think we are going to blast it, right? So, hi everyone, how are you all doing? Where are you all? I can't see anyone in the chat box. So, I think we have to make the session so awesome, right? So amazing, so energetic, so exciting. So, if this has to be happening, you all should be there with me, isn't it? Because the session is only gonna be super active and super energetic if we work for it together. So, yes, I hope everyone is there, and let's start with this amazing session of Rapid Sprint 2.0 with this topic of nuclei. So, hi Nick, hello. So, I hope you are ready to learn this particular topic. Okay, hi there, Nika. So, how are you? So, if we talk about the topics that we have completed, we have covered all the topics from the part 1 book of NCERT 12th standard, right? And from the part 2 book, we have completed till atoms, and today we are going to complete with that amazing topic of nuclei, which is actually a part of modern physics, you all know. Which means mostly you won't be listening to the word nuclei all the time, right, as a chapter, right? Because you will be listening to it as a modern physics, because modern physics is a combination of dual nature, atoms and nuclei, but each chapter has its own importance. That's why we took it separately and thought of discussing each topic together. Okay, you are in 10th, so no worries. Anyway, here we are just giving you some information. If you are okay with it, you can stay here and study this topic of nucleus. Okay. Fine. About me, yes, I'm good. I'm fine. It was a bit busy day, right? Okay, so I hope you all know about the Equivalence courses, right? Okay, top amazing teachers are going to be mentoring you there. So you can prepare for your JEE Advanced 2021 by being a part of Equivalence courses. So you can come and be a part of it, right? So you can take a screenshot of this. These are the course details. You can have 7 live sessions, right? Actually 3000 plus questions we are going to do it, and 18 JEE Advanced Test, 6 JEE Main Test. Oh my god, what else you need, right? So these are the commencing dates of the batches. Okay, 8th March, 19th March, 1st May and 28th May. Okay, so you can come and know more about it. Okay, the links are given in the description. And regarding the NEET 2021 test series, right, which means I hope you all know what a test series is, right, which means a lot much of tests are or will be conducted. And why we need to do this mock test? The first thing is it will take away all the pressure and all the excitement in your mind regarding the exam. Okay, so you won't be feeling scared or you won't be having any fear regarding this concept of exam. So after writing this test series, second thing, it is the best method to analyze how much you have learned. So if you really think that this NEET 2021 is a serious thing for you, this is the best thing that you can do for preparation as a part of preparing for it, right? So come and be a part of this test series. The link is given in the description. What do you have to do? Apply this coupon code of AMECC, right? Once you apply this coupon code, just for 1999 rupees you are going to get it, because the coupon code is actually giving you a 20% discount from 2499 to just 1999. Oh my god, that is awesome. So you can also be a part of it, right? Okay, so the starting date is 14 Feb. So you can be a part of it. Whichever classes you have missed, it will be there. Okay, then regarding this particular channel, before we start with, let me tell you, whatever happens here, everything is awesome. We have an amazing channel here. Lot many videos are happening just on the purpose of educating you, to make you learn all these and to make you prepared to crack all the exams. So don't forget to subscribe, because we are going to come with so many amazing videos. So make sure that now itself, now you move your cursor and get it done. And in the momentum with the Vedantu Telegram group. It's in this group. All the questions are being updated prior to the session. So you can be a part of it and understand all the questions even before coming to the session. What all are we going to discuss? Right? Okay. So hi Siddharth. Yes, I'm doing so good. Dharanika, no, I don't think the board theory is going to be started soon. So we have no information regarding that. Okay. So anyway, hi Siddharth, I'm awesome. Thank you so much for that. That means a lot as a teacher. Okay, so here we go with the very first question. I hope you all are ready for that. Right? Okay, so let's start. Mn corresponds to the mass of neutrons and Mp corresponds to the mass of protons. Fine? Okay. An element having a mass number, which means the element is having a mass, which means once you take this element, right, and once you measure this by using some method, it is having a mass, which means M corresponds to its actual mass. N is the number of neutrons, Z is the number of protons, then what is the correct relationship? Now, if a nucleus is having n neutrons, where each one is having mn mass, what will be the total mass of neutron? Total number of neutrons into mass of each, plus what will be the total mass of neutron? The total mass of proton, the number of protons into the mass of each proton. So this will correspond to the total mass of the nucleons, which means the total mass of neutrons and the protons, which means the total mass that was supposed to be there with the nucleus. But you know that the actual mass of the nucleus M is always lesser than the actual mass of the nucleons which it was supposed to be, isn't it? Okay, some mass is missing, and that missing mass we call it as mass defect, or the difference between the actual mass and the calculated mass. This is the calculated mass of the nucleus, this is the actual mass, this will be lesser. There exists a difference, and that difference we call it by the name of what? What do we call it? What do we call it? Yes, we call it by the name of mass defect. So which option? M is less than, so it is option A. Of course, I do love you. Hi Aditya, how are you? All good? So I hope you got this. Everyone in the classroom without having any issues. Is this concept clear? Yes, no, where are the answers? Where are you all? Okay, so moving on. Question. Yes, Vani, it's option, yes, A. Very good, very good. So everyone can give your answers. Okay, so before I give the answers, so let's see how many of you are actually participating in the quizzes. So jumping to the very next question, here we go. When P corresponds to the phosphorus element, right? Okay, or the nucleus of phosphorus with the 15 and 30 as the atomic number and mass is becoming silicon with atomic number of 14 and mass number of 30. Then the particle release. You can see that yes, decay is happening. So first you have to understand which decay is happening here, right? To understand the particle that is being released during this decay. Now, you can know that, or by looking, the mass number is remaining as a constant. If the mass number remains as a constant, it is a beta decay. Now, beta decay has beta plus decay and beta minus decay, right? So here you can look at the atomic number, it actually decreases. So if the atomic number is decreasing, it corresponds to which decay? Who is going to tell this? If the atomic number decreases, that corresponds to beta plus decay, isn't it? Okay. Now you have to tell me, in a beta plus decay, what is happening? In a beta plus decay, if you are having a proton in the parent nucleus here in the phosphorus, right? Okay, so you are having a proton. What happens to this proton? This proton is converted into neutron and another element which we call it by the name of positrons. Okay, so once this or during this conversion, right, the mass is almost conserved because the mass of proton and neutron are almost the same. The charge is also conserved because proton is having positive and this positron is also having the same charge as that of protons or electrons, right? Okay, which is a positive, and this is having a mass which is same as the electron. Electron is having very less mass compared to that of proton. So yes, this is what happens. So it releases along with neutron. Okay, a positron is also being released. Understood? Is it clear? Is it clear, everyone? Hi, I'm all good. Clashing Legends YT. Oh my god. I hope this concept is clear. No doubts. So moving on. Another question. Listen, it's very good, and it is mainly based on a formula from this decay part. So let's understand this, right? Okay. If 80% of a given radioactive sample is left undecayed after 1 day. So what is the equation to find out the available number of undecayed nucleus after a time of t? What's the formula? N, the present number of nucleus, is equal to N naught, corresponds to the initial number of nucleus, into e raised to minus lambda t, right? Okay. It says if it starts with 100%, right, the available after 1 day is 80, which means the available number of nucleus is 80, is equal to initial is 100, e raised to minus lambda into time is 1 day. The question is, what is the percentage present, right, after 2 days, which means the number of nucleus that is present after 2 days is the question. So N equal to N naught e raised to minus lambda into 2. Now we have to find out what the N value, right? Okay, so N is equal to 100 e raised to lambda. What we can do that for? E raised to minus lambda is 80 by 100, right? So I'm going to substitute that 80 by 100, the whole, what it remains, square. 80 by 100 is 4 by 5. So the value for N is equal to 100 into 4 by 5 square is 4 square is 16, 5 square is 25, 100 by 25 is 4 into 16 is 64 is the percentage that it remains. Okay, that is something which we can do. That Pakka, I'll try to do that, Dharanика. Fine. Okay, good. So Dia and everyone, Dharanика, Clashing Legends, who all we have in the class, is it clear? This is a very beautiful question based on the decay process. Yes, I suppose, without having any doubts. Simple sa chotu sa question. Yes, moving on. Shall we? Okay, so let's listen. Now there is a formula also to do this problem, but let's understand this particular concept question in a conceptual manner. Here we go. A radioactive material is reduced to 1/8 of its original amount in 3 days. Okay, so how much material should begin? Okay, what is the initial number of nucleus, so that after 6 days what it left is 0.09 kilogram, right? So how it can be done? Okay, let's see. I do love Vedantu, Ayush. What about you? Don't you love it? Okay, let's see how it can be done. Let's first analyze the first statement in this question. A material is reduced to 1/8. You know that if there is N naught number of nucleus, it will be converted to N naught by 2 in 1 half-life, right? In 1 half-life. In the second half-life, this N naught by 2 will be converted to its half again. Or let's do it in this fashion. Okay, so let's do it in this fashion. So in the first half-life, it becomes N naught by 2. One more half-life, what will happen? It will become half of that. N naught by 2 is N naught by 4. And again, in the another half-life, it is becoming N naught by 8, N naught by 4 by 8. So it is actually taking once the half-life, second half-life and third half-life. So 3 half-lives are being taken for this particular nucleus to become how much? To become 1/8 of it. And how much is the time taken? 3 days. So for the nucleus to become 1/8 of its initial value, it takes 3 days, and this 3 days corresponds to 3 half-lives. So 1 half-life is equal to how much? That is equal to 1 day. Understood? Okay, so in 6 days, One half-life is 1 day. In 6 days, it corresponds to 6 half-lives, isn't it? Right. So 3 half-lives or 3 days is done. We'll have n naught by 2. On the 4th day, half of it again by 2, that is 16. Okay, one more t half. One more t half, n naught divided by 64. Understood? 2, 4, 8, 16. 16 into 2 is a 32. I'm sorry. And again, that one more half life is n naught by 32. And one more t half is equal to n naught divided by how much? 64. Right? So how many half-lives are being taken here? It is taking 6 half-lives. 6 half-lives corresponds to 6 days. So in 6 days, how much will be the available amount? N naught by 64. N naught by 64 is given as 0.009. Understood? So N naught will be equal to how much? 0.009 into 64. How much is it? How much is it? We are going to get the option B as our answer. Is it clear? Is it clear without having any doubts? Simple such obtuse concept. Okay. A similar kind of question is what you can see right in front of us. Okay. What is it talking about? Listen, everyone listen to this question. The half-life of a certain radioactive substance is 40 days. Which means if initially there was n naught, it becomes n naught by 2. This is what you mean by half-life. Okay, the time required for the molecules to become half of whatever it was available initially. That time is called as half-life, and that time is given as 40 days. In 40 days, it becomes n naught by 2. How long will it take for 75% of the substance to disintegrate? If 75% is disintegrated, how many will be remaining? 25% is remaining. Now, we know that in the first half-life, n naught by 2. And if I take one more half-life, another 40 days more, whatever is left, which is n naught by 2, it will become half of it, what we were explaining in the previous one. Okay, what is half of n naught by 2? That is n naught by 4. What is n naught by 4 corresponding to? That is corresponding to 25%, which means after 2 half-lives, after 40 plus 40, 80 days, the available amount is 25%. It means 75% is being disintegrated. So here, yes, we have satisfied to the condition of the question for the disintegration of 75%, or for the molecules to be having 25%, how much days it took? 40 plus 40, 80 days. Understood? Is it clear? Okay, so let's do another problem. Here we go. So listen, the energy released in the following beta decay process will be, how much is the energy released? Now we know that all the energy released during the nuclear process is because of the mass effect, right? Because of the change in mass between the product side and the reactant side. Okay, so this energy is given by the mass energy equivalence by Einstein. What is that equation corresponding to? If you are having a delta M mass with you, the amount of energy that can be produced is equal to delta MC square. So first you have to find out the change in mass or the mass effect between the product side and the reactant side. Okay, so that is equal to sum of mass of the product. Okay, you have to subtract it from the sum of mass of the reactant. What is the mass of reactant? That is mass of neutron. That is 1.66747 into 10 power minus 27 minus mass of protons and mass of neutrons are what we are having on the product side. 1625 10 power minus 27 plus 0.00091 into 10 power minus 27, right? Okay, into c square. What is c? Velocity of light. So 3 into 10 power 8 the whole square. This is in the unit of joules. How will you find out the energy in electron volt? dividing this energy in the unit of joules with 1.6 into 10 power minus 90. And the final answer you're going to get is option C, which is 0.731 electron volt. I hope you all know this formula, Einstein's mass energy equivalence relation. Right? Don't you all know? Yes, Diya, Dharanika, Achitesh. You all know it, right? So just apply the values here. That's all you want to do it. Nothing more. So yes, moving on. What do we have in the next? An atomic power reactor furnace can deliver 300 mega, means 10 power 6 watts. What means that much joule of energy can be delivered by this power reactor in a second. Now, the energy released due to fission of each uranium, which means if uranium undergoes fission reaction, you know fission reaction means, right, a heavier nucleus is split into two smaller nucleus. During that process, energy is released, and that energy is 170 million electron volt, right? Okay, so the number of uranium atoms fissioned per hour will be, okay, how many uranium nucleus is undergoing fission. For that, we have to understand in 1 hour how much of total energy is being produced by this reactor. In 1 second, it is this. Into 60, it corresponds to 1 minute. Into 60 will give you the amount of energy delivered by this atomic power reactor in 1 hour. Now, you know that 170 into 10 power 6 electron volt, right? Into, how will you convert it into joule? By multiplying it with 1.6 into 10 power minus 19. Now, this is the amount of energy given by one uranium. So, for producing this much of energy, the number of uranium will be equal to how much? Total energy required by energy released during the fission of one uranium will give you the number of uranium which is undergoing fission reaction. Understood? Simple, right? Very simple. And how much we are going to get? We are going to get the option C, which is 40 into 10 power 22. Simple as that. Got it? Are you all happy with the session? Whatever we have discussed it here without having any troubles, right? Which means you all are happy. You have to be happy. So try to do more number of problems based on, because we have tried to cover a maximum number of problems, including, right, all the theories. I have explained all the theories related to the question. Everything is clear, I suppose, right? So if everyone is happy about the session, if you think that yes, you have gained some new knowledge about the chapter, did some new questions, what do you have to do? A small favor to all the teachers in this channel, move your cursor and just click on that like button and share it with your friends, because your friends are also going to get benefited. They are also equally preparing for the exams, right? So ask them to come and join here in the classroom at this time. You'll also have a company, and I'll have one more student in the class. And yes, subscription. I think I don't want to explain to you why it is so important. I think we have some new students there and all, right? What do you have to do? Move your cursor, click on the subscribe button, okay, and on the bell icon also, because once you do this, all the videos what we do here, you will get the notification, right? And you can be a part of this live classes all the time. You're not going to miss it. So make sure of it, okay? And thank you so much. Till we meet next time. Bye everyone. And yes, take care.